Hello, Hornets, and welcome. Today we're going to be taking a look at absolute and conditional convergence. And in order to look at that, first of all, I just want to make sure that you are all aware that the theorem that we're going to work with is if the series, summation of the absolute value of a sub n converges, then the series, I keep saying the series summation without the absolute values a sub n must also converge. Alrighty. Now, please be aware when we are talking about absolute convergence and conditional convergence, we're talking about alternating series. Okay? We're also talking about Opie and Ellen as opposed to a P series or a geometric series. So we're saying that when we don't have a negative 1 to the n or a negative 1 to the n plus 1, Ellen and Opie, they don't make it. They can't come in, right? Ellen and Opie are too slow. They can't get to the concert converge. The mathematical concert phenomena. Well, they're in the city. After all, Converge only plays in the city of zero, and if you want to go to the concert, you got to get to the city first. How else can you get to their stadium or their venue? All right? Now, Ellen and Opie get there too slow. But when Ellen and Opie get aggravated, they get angry, they get negative. Negative 1 to the nth is added to them. They will now converge by the alternating series test. They're an alternating series and the limit at infinity goes to 0. Two criteria met, they will converge. But if you take that negative 1 to the n or negative 1 to the n plus 1 away, they're too slow again. They don't get to converge. The only way Ellen and Opie can converge is if they have a negative. This is the alternating series. It's the alternate door to get into the concert. Get in an alternate way, using an alternate series, being negative. Okay? That's how Ellen and Opie can converge. That's how they get to the concert. But if you put absolute values around Ellen and Opie, it takes away the negative 1 to the nth. It takes away the negative 1 to the n plus 1. They are now back to being too slow, and they do not converge. That's what we're talking about. So let's just take a look. Notice, if I take the absolute value of this series, negative 1 to the n plus 1 over n squared, I'm looking at 1 over n squared, a P series where P is greater than 1. And in a P series where P is greater than 1, I have a convergence. So not only is it converging because it now satisfies the alternating series test, the limit as the absolute value of negative 1 to the n plus 1 over n squared, where the limit as n approaches infinity goes to 0, check. We also can see that it's an alternating series, therefore it has to converge. When we take away the negative 1 to the n plus 1, we're still looking at a P series where P is greater than 1, and therefore the series still converges. So notice this series converges just as much as the one above it. This is the idea of the absolute value of the summation. So when the absolute value of the summation converges, we have an absolute convergence. Let's see one that isn't absolute. See how this is a P series where the P is the power of P, or P is less than 1, it's an OP. So if I take the absolute value of this series, I end up getting the series that's OP. And OP doesn't converge because n is between 0 and 1, or the p. Let's put it as the p is between 0 and 1. Here, OP fails, but here, OP passes. Here we have convergence because OP is now negative, alternating in series, goes into the concert, converge through the alternate door. Not negative, therefore not converging. This we say is conditional. The condition is the negative 1 to the n plus 1. In the previous example, this is absolute, because when I take the absolute value, I am still looking at a series that will converge. Here, conditional, because if I take away the negative 1 to the n plus 1, I now have an OP that will not converge. Therefore diverge, and the conditional convergence is what we have. So this is what we're looking at, all right? We always want to determine if I have an absolute convergence by taking away the negative 1 to the n plus 1, or negative 1 to the n, or cosine of pi n, all right? We take away the negative, and we look at what we have. If we have an OP, or a power that is between 0 and 1, or we have an ln, a natural log in the denominator that does not have a power that is greater than 1 for it, it'll converge only if we get a negative 1 to the nth. We call that conditional. That's the idea behind conditional and absolute convergence. I hope this helps. Please let me know if you have a problem with the video. Thank you very much. Have a wonderful day. Take care and be safe, and good night. And remember, it's easy to be mean, so be nice to each other, work harder. Change starts from within. Thank you very much, Hornets, and have a wonderful evening.